Okay, so moving on with Three.js, I'm going to show you loading tools for various 3D content formats, various meshes that one can load. Let me get a share screen going here. So before I do this, I found this an excellent website that has a pretty thorough introduction to a lot of different aspects of Three.js, many of which I haven't actually covered. And also I found this absolutely insane site that from Mr. Doob that has things that I have no idea how he does with Three.js, but it's a tool that he uses. So anyway, we've talked about lights and particles and image effects, and today I want to talk about this importing 3D file formats, various formats, including JSON, Obj Mtl, Colada, and others. Three.js has its own JSON format that you can use to define a geometry or scene. I gather this is not official, although Blender seems to export in JSON, and it's pretty easy to use. So one of these loaders would be a new Three.json loader. This has to be added in the .js's that you add from the library. And then we load the model that we want to load, which itself is a JavaScript. We have a function for defining the different properties, the geometry and the material. We add that mesh to the scene, and we've got the URL for the texture if it has one. And here's what this kind of looks like, a nice little chair that we can rotate around. And looking at the .js, we can see that all of the different features that we've been talking to are included here. We've got vertices, faces, normals, colors, UVs, materials, bones, which of course we're not doing, so it's 0. And then the materials have colors, index, the object name, ambient, diffuse, specular, type of shading, shininess, transparency, a lot of other things. Then going on further, there are vertices that are all displayed in one great long string of floats. We've got the normals that are a whole bunch of floats, the UV maps, all of the U's, all of the V's apparently. And then as you recall, when we were talking about displaying polygons, one of the more efficient ways to do it was to load all the vertices and then define the faces with a list of the vertices. And that's the approach that is taken here. So we have the faces, each of which have lots of face vertices. I actually have a view into one of these. Here's the JSON for the little chair. Here are all the different vertices extending out forever. Here are all the normals. Here are all the UVs and all the faces. And you can see it's not a terribly human readable format. And there is something that'll export scenes in this format, but I haven't discovered it yet. So another format is the object format, OBJ. And again, we have a loader that's just a Obj loader. And then we load the model. in this case a little pine cone, a function that defines how we're going to open it. This goes through the various children in our material. It defines a material with a color. I don't see a place for putting textures into this. Actually, that comes later with the next format. But the OBJs are familiar in the sense that we have an object, a plane, then we have a whole list of vertices, and then somewhere down here, far, far along, we have the faces that are the 4 vertex locations in this vast list of vertices up here. So again, it's a format that runs all the vertices, but has this connectivity array that defines the vertices that comprise a given face. Now, a companion to the OBJ is the MTL format, and this is a file that specifies the materials of the objects in an OBJ file. So we have the Obj Mtl Loader that takes the different objects, the wings. This is a little, oh, here's the OBJ, by the way, the pine cone. But here's the Obj Mtl. So now we have an object file, Obj, that's defining the geometry of this, but we have the MTL that is specifying the textures that lay on this. And again, we have various properties that we're setting, opacity, transparency of the 2 different wings and the object. And then we're loading the butterfly object, the butterfly MTL, and here's a specification that we want double-sided objects so that the wings are visible from both sides. MTL looks like this. We can see the specification here of the body has a specular exponent, ambient, diffuse, and specular colors. I'm not sure what Ni and D are. The eyes have a shininess, an ambient, a diffuse, and a specular. And each of the different components of our body get these. Here's one that includes a PNJ for the wings. So this is a texture that's included in the wings, but it also has ambient, diffuse, and specular components, as well as a shininess exponent. The Colada is a rather common format. A lot of 3D applications and rendering engines support Colada. The loading here is a Colada Loader. It has the Colada file that you're going to include, and I believe it goes on and actually includes the various textures and so forth that are needed by it. The Colada format is in XML, so those of you who are familiar with XML know how this nesting thing works, but it has all these different colors and faces, and somewhere are the vertice counts and the colors that are loaded. And this one is quite robust in terms of different textures and colors and so forth available on the model. STL from Stereolithography is one that's used with 3D printers. And so if you like to look at what your object is before you print it. This is a common way of doing it. Again, an STL loader. This is done with a group. We'll talk about that in a little bit, where we're loading the STL and going through and adding the different elements of our object. This looks like this. We've got a head here with, in this case, a Lambert material with this color. And the STLs, for what it's worth, are in binary, so these are not human readable formats, but they're usually created by some software. CTM is another format based on 3D triangle-based meshes. CTM loader, again done as a group. We've got a wheel function that we define the geometry. Here's the color and the mesh and the scale, and we're adding it to our group. And the CTMs, I believe, are also another binary format that's not human readable. CTM looks like this. Here's our little wheel defined with all the different vertices. The color appears to be just defined right here. VTK, Visualization Toolkit format, specifies vertices and faces. 3JS appears to support only the older ASCII-based format. It's a VTK loader, again with a group. The object we're loading, the geometry, and the color. So it's very similar to the previous one there. VTK looks like this. Here's a little object with a color specified here. And its format is also familiar. We have a whole bunch of points all laid out. These are X, Y, and Z points. Somewhere down here are the faces. These are triangles, so they have 3 vertices, and this is the index list that we talked about in class as a more compact way of storing things. PDB is, stands for Protein Data Bank, is a format for displaying molecules, proteins. It basically gives you a model of some chemical. This, I believe, is diamond. And so we have these hexagonal arrangements that make the diamond so hard. And in this one, we're specifying the position of the balls and who they're connected to. And so if we look at the PDB database, it's a whole bunch of atoms with their X, Y, and Z positions. And then down at the bottom here, it's which one is connected to which other one. So atom 1 is connected to atom 66 and so forth. And with diamonds, we see as many as 5 connections between any of the different molecules. It's using a tube. We'll talk about those later. PLY, polygon file format, comes from scanners. In this example with the PLY loader, we're loading it from test PLY. We've got a geometry with material, color, size, opacity, and I believe we're displaying this as a point cloud somewhere. The PLY, in this case, displays the vertices as a point cloud. They're particle basic material, so that's why they're displayed as points. So that's importing the different file formats. One other thing I want to do today is deal with the grouping of objects. We saw in the last thing that there were references to groups, and groups allow us to kind of put two objects together and manipulate them as a single object as opposed to individual objects. Let me close these out and start another HTM. So let me start these two here. So grouping. So with grouping, we can either add objects individually, or we can add them to a group and then add that group to the scene. So here I'm creating a sphere and a cube separately. I'm setting their position separately. I'm declaring a new group. It's of type Object 3D. And I'm adding to that group the sphere, adding to the group the sphere, and then the group is being added to the world. And so these two objects, the sphere and the cube, comprise a single object. Now, to demonstrate the difference of that, I'm in my render where I'm rotating these different objects. If the rotate flag is set, I'm going to rotate the group about its y-axis. If the grouping flag is not set, it's going to individually rotate the sphere and the cube. So turning on the, with the grouping off, I turn on rotate and the two objects rotate about their own y-axis. But if I turn grouping on, now it rotates about the center of that group of objects. And if I move things around, I'll let you play with this yourself, with playing with the position of the sphere and its size and so forth. These are all accessible from the menu. I'll let you play with that yourself. Another feature that you might notice here is this bounding box that is wrapped around the objects that shows the minimum and maximum extent of that combined set of objects. And this is done by a function position bounding box that's going to build up this bounding box. We're going to call this set from object group, which I'll show you in a second. And then that returns the box that has a min and a max and in all three X, Y, and Z. So I'm making my bounding box as a little cube with width, height, and depth, width, height, and depth. And I'm displaying that as a wireframe with line width 2, and I'm adding that to the scene. This set from object is a little tricky. It accesses something called the world matrix that has to be updated. And I'm guessing this probably has something to do with the current transformation matrix for the object. So when we set from object, we update that world matrix. We have this box objects that's a three-dimensional box with three-dimensional vectors for the vertices. We make it empty, and then we traverse the object. That's the group. Looking for nodes. Each of the nodes, if it's a geometry and it has vertices, then we pull the vertices out of it, go through the vertices, and apply them into this V1, which we then expand the box by adding the point to it. So that means that this is going to expand and contract to contain the entire object. And of course, if we're not grouping, well, it does expand and contract as the little edge of the box goes forward there, and it returns the box. Now, another feature is the ability to merge individual meshes into a single mesh. And this can provide a major improvement in performance. So with this next one that I'm going to show you, merging, we've got all these different objects. Let me reload that. So maybe it's full screen. Okay, so I've got all these different objects. If we're not combined, which we aren't here in this initial setting, when we create the object, we're going through all of the different objects and adding each individual one to the scene. When it is combined, instead of adding each individual object, I'm going to make a geometry and go through the objects that I'm created and merging them into the geometry with the add cube. Add cube, incidentally, is a function that just makes a little cube of a given size with a material and sets various properties of it, including a random position, and then returns the cube. So to really stress test this, let me crank up the number of objects here and turn off combined here. So here are my now 5,000 different objects. And if you look at the frame rate over here, the frame rate is running at about 8 frames per second. We've got, it's barely showing on the list. Whereas if I combine it, the frame rate leaps up to 60, and we're able to display this now single object that we can rotate and manipulate and do things with. Unfortunately, it appears that one can only have one color on a merged object, one texture, one material. At least without accessing all of the different vertices of this, I haven't seen a way to actually assign different colors to this. So that finishes what I want to do here with the loading of different formats and the grouping and merging of different objects together. Let me end the share screen here. And I'm going to end the recording now, and I'll see you all in class. Stay well. Bye.